Hello everybody, Root Beer here once again with more math contests. Specifically, we're looking at question 23 on the 2001 grade 8 Gauss paper. So what does question 23 have to offer us in the way of a challenge? Well, question 23 says, the integers 2, 2, 5, 5, 8, and 9 are written on 6 cards. Here are our cards. Any number of the 6 cards is chosen, and the sum of the integers on these cards is determined. Note that the integers 1 and 30 can't be obtained as sums in this way. So we can't get to sum of 1, because the lowest card is 2, and that's already too big. And 30, we can't get 30, they say. Okay. How many of the integers from 1 to 31 cannot be obtained as sums? Alright. So I'm not noticing any patterns with 2, 2, 5, 5, 8, and 9. So it's not like they're a well-known sequence of numbers like powers of 2 or the Fibonacci numbers or anything like that. So I don't have an immediate mathematical instinct for this question. But I do know that we're talking about the numbers, the integers 1 to 31. And they're already telling me that 1 and 30 can't be done. So I'm thinking maybe I just grab combinations of these cards and see if I can work them out. See if I can work out their sums. Now, I want to be methodical about this. I don't want to say, oh gee, can I do 5? Or can I do 6? Well, I've looked at it and I don't think I can do 6. I want to be methodical. I want to pick my cards in a particular order so I know I've gotten all the possible sums. And then I can just see, oh, was 15 ever in my list? Oh, it was. Okay, was 17 ever in my list? Oh, it wasn't? Okay. So we're going to figure out all the possible sums, but we're going to do it in a very straightforward and logical step-by-step way. And that's the key to doing a question like this. Okay. So we have cards 2, 2, 5, 5, 8, and 9. All right. So, it's probably best to start listing them out. So I'm going to say, well, what can we have that has a single 2? So the sum of just a 2, well, that's a 2. Or we can have the sum of 2 and 2. That's 4. Or we could have the sum of 2 and 5. That's 7. Or we can have 2 and 2 and 5. That's going to be 9. Or we could have 2 and, well, we're not going to use this 5 because we've already accounted for that, so we'll jump all the way up to 2 plus 5 plus 5. That's 14. And, alright, so I'm starting to do these, and I'm not exactly being the most methodical I can be. So, you know what? We're actually going to do the 2 plus 5 case. We're just going to include them all. Okay? That way we don't miss one. I was going to start trying to be fancy and saying, well, we only need this 5 if we've also got this 5, but I don't want to miss anything. So that's 9. 2 plus 5 plus 5. That's a new one. That's 12. That's going to be 12. Okay. How about 2 plus 2 plus 5 plus 5? Well, that's 14. All right, now we're going to jump up to 2 plus 8. And that's 10. And we're going to do 2 plus 2 plus 8. And that's 12 again. 2, 5, and 8. Well, that's 15. How about 2, 2, 5, and 8? That's 17. Okay. 2, 5, and 8. Well, we already talked about that one. That's 15. 2, 2, 5, and 8. That's 17. 2, 5, 5, and 8. that's going to be 20. 2, 2, 5, 5, and 8. That's going to be 22. So now we've used all these. Let's add in a 9. 2 and 9, that's 11. 2, 2, and 9, that's going to be 13. 2, 5, and 9, that's going to be 16. 2, 2, 5, and 9, that's 9 plus 9, that's 18. And now we're adding in that extra 5, 2, 5, and 9. Well, we talked about that one, that's 16. So 2, 2, 5, and 9. We talked about that one already. 2, 5, 5, and 9. 18, that should be 21. 2, 2, 5, 5, and 9. So that should be 14 plus 9, that's 23. And now we'll add in that 8. So that should be 21. 2, 2, 8, and 9. 2 plus 8 is 10. So that should be that should be 23. Oh, sorry, this one should be 19, and then you get 19, then 21. 2, 5, 8, and 9. That's going to be 15 plus 9, that's 24. 2, 2, 5, 8, and 9. That's going to be 9 plus another 9, that's 18, so plus 8 is 26. 2, 5, 8, 9. We already did that. Oh, yeah, we already did that. That was 24. 2, 2, 5, 8, 9. We already did that. That's 26. 2, 5, 5, 8, and 9. We haven't done that. So 10, another 10. So we get 29 here. And we should get 2, 5, 5, 8, 9. That's all of it in total. And that's 31. Okay. So that was all the ones that just involve at least 1, 2. Now we don't need to do the same thing for the second 2. We'd just be repeating ourselves. Okay. And we're trying to cut down on repeats. So that was everything that involves at least 1, 2. So now let's see what happens if we have no 2s. Well, we can have a 5 for a total of 5. We can have a 5 and a 5 for a total of 10. We could have a 5 and an 8. That's 13. We could have a 5, and an 8. That's a total of 18. We've seen 18 before. We could have a 5 and a 9. That's 14. A 5, and a 9. That's 19. A 5, an 8, and a 9. That's 13 plus 9. That's 22. If you're curious as to the way I'm going through this with this particular pattern, you might want to look up binary numbers. They give us a nice 27. I don't think we've had 27 before. Binary numbers give a nice way of choosing whether or not something's in or out. And since that's all the ones that don't have 2s, but we've still reached all numbers, this should be everything that's got at least one 5. So now how about everything that's got at least an 8? Well, 8, 8 and 9, that's 17. And that's everything involving an 8, so there's just 9 left. Okay. So, let's see, who have we got here? 2, 4, I saw a 5 already. We haven't had a 6, so. Had a 2, we've had a 4, we've had a 5, so we'll cross some of these off. 7, 8, and 9. We haven't had a 6 at all. So 7, 8, and 9, we can cross any of those off. And that does it for that. We've had a 10, we've had 11, 12, 13, 14, 15, 16, 17, 18, 19. Have we had a 20? Yeah, we had a 20. Let's start crossing these off. So I think we can get up to 20 now. 13, 14, 15, 16, 17, 18, 19, 20. So there's 19, 14, 18. There's our 16. Oh, there's a 17 right there. And we had some 15s on the other side. So there's 15, 17, 15, 17, 12, 10, 14, 11, 13, 12, and so we got 20. And that does it for this side. 22. So now we won't need to flip back to this page, so we'll add 22. And we also have 21. So 21, 22. We can get 23. We got some 24s. No 25, but we have a 26 and a 27. No 28, but we have 29 and we have 31. Okay. We were asked how many can we get? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So 25 out of the first 31 numbers. The only things we're missing are 1. I'm counting on my hands here. So we're missing a 1, a 5. We should get a total of 6 here. A 1, a 5. We're missing 25, 28, 30. Did I count wrong? 1, 3. Oh, 6. We're also missing 6. 1, 3, 6. 28, 25, and 30. Okay. So we got the right numbers either way. So we have a total of 25 numbers that we can count on. And how many numbers cannot be obtained? So 6. 25 could be obtained, and that leaves 6 that we can't have. Okay. So our answer is going to be go on, flip page. Did I not? Yeah, there it goes. Okay. So 25 can be obtained. 25 out of the 31. So that leaves 31 minus 25 equals 6. Cannot be obtained. And that is E. Okay? So E6. So we got 2 more questions to go. We're going to take a look at question 24 on the 2001 Grade 8 Gauss paper in the next video. So join me for that. And as always, have a good day. I'll see you then.